Alrighty, are we live? I think so. Say hello, man. It's kind of late. Just keep my voice down. Turn up. I'll whisper. I'll turn up the volume on the microphone. So hello and welcome. Hope you're doing okay. Yeah, it's very late, so I shouldn't. Well, let me turn up the gain somewhat. I have to remember that I turned up the gain. So it's gonna be, I have to keep my voice down. Really have to keep my voice down. So the deal is, that's maybe too much. The deal is, I just want to say hello. I get kind of I don't know. I don't know where to begin, what to say. I have this tendency to try to move very quickly sometimes. And it just doesn't work out. It's just sometimes just doesn't work out. I don't know. We'll see. I'll be cutting it pretty close, but there's something I'm working on that I can't really give out too many details, can't really talk about it too much, but let's just say I tried to get things to work out, kind of how to express it. I tried to line things up, and it didn't line up properly. Or at least not as I expected. It might still work, but we'll see. I'm working on it. Yeah, like I said, I can't really give too many details. Just the nature of the thing. But it's really caught my attention lately. It's like all I can think about. For good reason. Also, don't want to give too many details as to why. But just trust me, it's important. It's important. High priority. Yeah, we'll see tomorrow how things play out. I've got to remember to do some things tomorrow. I have to read the Bible. I haven't been able to read the Bible because I've been so hung up. And I've been, solving some problems here and there each night. I like doing that. I mean, I don't know. There's a lot to say. I won't go into too much detail, but let's get into the problem. Let's do that. This is what the video is supposed to be, is solving the problem. So let's do that. I'll say I have my glasses on today because I getting kind of tired of, the idea is to not wear my glasses. That way my eyes kind of hopefully improve somewhat over time. But I don't know. I'm getting kind of sick of doing that because I have to bend over to see the screen, and my back has been through enough abuse in my life. Not like it's been abused too much, but it's just seen a lot of use, and I don't really want to keep straining it too much if I don't have to. So I'll probably stop doing that too. But anyway, let's take a look at this problem. So flatten 2D vector is the problem, and we'll see what it's in store. We'll see what's in store. Let's take a look. Let's take a look. Okay. Design and implement an iterator to flatten a 2D vector. It should support the following operations: next and has next. So iterator, new vector 2D, 1, 2, 3, 4. Iterator next, return 1, next return 2, next return 3, has next return true, has next return true, next 4, has next false. this is pretty simple, what they're looking for. Only iterators in C++ or iterators in Java. Interesting. I'd just like to add these. Yeah, interesting. I forget. Okay, yeah, well, I don't have to do this too often. It's good practice. Yeah, I definitely I don't do too much work with iterators. Let's find out. So something, I think this is a relatively simple question. The mechanics of it are I'm going to end up struggling with, but you could just look up, more about iterators, and how to implement them and all of that. But I think the simple thing we're going to do here is next. So the iterator is going to have a position in the two-dimensional vector. Once instantiated, we'll start at sort of position 0, 0. You can call it row column, right? Row 0, column 0, and use that index in the vector to get the integer there. And then so you return where it is, and then next we'll increment the row column. And so what'll happen is doesn't really give much detail on these operators. Reset your class variables, declare and persist across multiple test cases. Interesting. Huh. Next will always be valid. I was gonna say, it's at least the next element when it's called, right? Yeah, you wanna have a couple things here. Vector and exception. Yeah, if it's not valid, then you would want to throw. But yeah, I think the logic is really straightforward. When you call next, you return whatever's at that row column position, and then you increment the column. And if that column is beyond, if it's greater than or equal to the size of the row that you're on, then you're going to decrement the column back to 0 and increment the row. And then if your row is greater than or equal to the size of the number of rows, then you actually throw at that point. That's it. Super simple logic. And the has next is oh no, excuse me. When you return 4, no, I take that back. You increment the row, and then before you return, that's when you throw. Yeah, before you return, that's when you throw. And the has next is just a check on the row value. Should be what gets checked. You don't really need to check the column value, because that'll always be in a valid range. Tricky thing here, slight, very nuanced, very slight thing. If you have empty rows, you may have a problem with that logic. So actually you may have to increment your column. In other words, if you if you increment your column past the row, you know, outside the row, increment your row. However, if that row is empty, you want to keep incrementing your row. Right. Until it's not. This doesn't about the rows being empty. So there's a slight, tiny little nuance here. Yeah. So we'll just throw a while loop in there to handle that edge, sort of edge case. But there's pointer, there's like a pointer operator that we're going to use here. But iterators are pretty simple. I mean, they basically just have like state that they keep track of, and you just kind of move one state from one state to the next. Wow. It's been a while since I've been on Stack Overflow and looked at the jobs. There was a period of time where I was constantly looking at all the jobs that were available. Yeah, wow. Anyway, here. It's time for bed. Oh, my knees. Oh, ouch. Oh. Yeah, there are a few things here. Also, I don't have a toothpick. I've got something in my teeth. The thing about iterators, it's probably something I need to study more about, learn more about. Like, there are a couple things about iterators. So the first thing is, like, you would want to have hold on. Okay, so it's a new pointer. Alright, I'm just thinking. Fair enough, okay. Obviously I have to overload this. You know what we don't have is the dereference operator. Yeah, there's a couple things. So there's the assignment operator, dereference operator, swap operator. That's really interesting. Usually have an increment operator as well. That would be like the next operator. In our case, they're not asking us to they're not asking us to I forget what this is called, this operator. Yeah, that we need that one too. They are asking us for that. Well, not really, actually. Yeah, because this is a pointer inherently. So really we don't actually really need very much to implement this, to do it sort of what they're asking for. Like an iterator would have some things, I guess. Would have those other operators defined, but we actually don't really need to do that. Okay. So you'd say row, column, and you'd say if. You could even just do if not as next. What do they call that? You'd actually have a null pointer exception. Something like that. Technically, yeah, it would be a null pointer exception, trying to dereference something that's not pointing to anything logical. Actually, you really do it this way. Actually, that's a little confusing. This pretty much should always be true. And then you say if that's an empty row, Then you're going to increment the row again, and this should be true again. And if it's not empty, you'll exit the loop. Yeah. Okay. That's exactly what we want it to look like. That's pretty much it. Yeah, you always increment the column. The column is greater than or equal to the row size, then you set the column to 0. And increment the row, go to the next row. And yeah, and then all you've got to do here is just say yeah, that's it. Oh, excuse me. Oh, I see. That's my mistake. I don't know if this works the way that I would like it to. That's my mistake. I completely forgot. Yeah. That's a tricky thing. That's a tricky thing. The problem with this is, I don't want to copy the matrix, you know? Oh, that's very awkward. You can actually do something kind of interesting here using row iterators for the row and the column. This is a very tricky thing here. So, okay. Yeah, okay. Alright, you ready for this? You ready for this? Alright, let's do it. if I could do this. No, I don't think I can do this. Can I do this? I wanted to try to use Iterator somehow, but the problem with that is I need a reference to the matrix in order to get the beginning and ending iterators that I want to use, which I don't have. So that's pretty tricky. Yeah. That's a little tricky. No, wait, go back. You can do that. No, it still works. I'm sorry, I take that back. Okay. It's still tricky, but... Okay. Oh, that's confusing. Okay. So I have row, column, iterators, start V at the beginning of V. If row is not the end of V also, or in other words, as long as V is not empty, we can set the column at the beginning of the row. Now we'll say this is going to be, there's a row pointer and a column pointer. We actually want column to dereference column. That's what we want to dereference. And we're going to say, plus column. If column is not equal to, it's going to be the row end. Then we say column equals, and we're going to set it to 0. But here it's going to be row begin. And we're actually going to go ahead and say increment the row while the row is not equal to the end, which actually we do need that vector as well, or that yeah, we do need that to hold on to that. No, we won't know. We won't know where the end is for the row without that. And matrix row size, we'll say column equal row begin. And we say, and really it's just the column's not equal to the end. increment the row, and the column will be in the right spot. So increment the row. You can do, gotta be careful here. Yeah, you have to be careful here. Just think here. Keep incrementing the row. Really, you want to say if row is not equal to row end, then you update the column to the row beginning. Otherwise, it doesn't matter what the column is after that. The problem with this is that you don't want to update the column. You don't want to update the column to. So if the row is the row end, and you call this column, this will throw a null pointer exception. That's the issue. And then real simple, something like this ought to do the trick. I didn't really think about it too much. We'll just test it and see what happens. No viable overloaded. What? Oh, of course. Interesting. Okay. Okay, makes sense. Apparently these need to be const. Kind of misunderstood that. Okay. What do these need to, what is this? What? What am I missing here? What am I missing here? Methods not marked const. Class normal iterator. Candidate function, the implicit move assignment operator not viable. This argument has type. But method is not marked const. Do you need that? Not allowed on a quality constructor. Cannot have a return type. Yeah, no kidding. Huh. What is this? What? Okay. This is a little unusual for me. Okay. Constant rigor. What's the type of this iterator? Is that what I need? Really? No kidding. Okay. Oh, there's no way to... Huh. Hmm. Guess it doesn't matter what the column is. If it's garbage. Just thinking. Yeah, I guess the column. Gets set to the row begin. We can make this row end. So if you're looking at the end already, you don't care what the column is because this will always return false. Right, interesting. And when does this happen? What's going on? Why do we get terminate calling if the right instance of runtime error? Really? Okay. Just do some debugging. Just want to make sure this is not the runtime error that gets called. Oh, it is. Huh. No kidding. Wow. What happened? One. Excuse me. How do we do? How do we do? Oh man, my teeth. It's not comfortable. Need to go to bed. Count 1, 2, 3. No kidding. Yeah, okay. That was a mistake on my part. Heap buffer overflow, no kidding. Check 1, 2. 1. Count 1. Oh, made a mistake. This should be equal to, not, I did that twice then, huh? There we go, okay. It gets a little confusing. Okay. Yeah, that's quite confusing. I'll explain what's going on here. So, what happened is, I basically mixed up with pointers the way to figure out if a pointer sort of moved past the end of the range that you're iterating on, or with iterators, if you move past the range that you're iterating on. The way to know that is to compare it to an end pointer, or an end iterator rather. And if you're equal to the end, that means you went over the range. And it becomes kind of a double negation, because you're saying if it's equal, then you've gone over the range, which is usually a negative condition, that you've gone past, that the wrong thing's happening. Yeah, so I often confuse that with not equal to the end means you're in range. So you have a double negation, right? Not, and then end meaning over the edge. If you're not over the edge, then you're in range. So you have this sort of double negation that happens. In my brain, when I'm juggling all these different things at the same time, I just kind of struggle, and so I got confused. So this is supposed to be if you're out of the range for the column, then you need a new row. And you have to make sure you skip over the empty rows, which means that the beginning is equal to the end for that row. But if you don't want to go too far with your rows, and then you want to make sure that if you haven't gone too far, meaning you're not equal to the end now, then you can set your column pointer to the beginning of that row. If you have gone too far, then this will give you a null pointer exception. So you gotta throw that extra check in there. And right, as long as you're not over the edge, not equal to the end of the rows, you should be in good shape. Let's go for it with this one. So this is pretty interesting. The reason why I wanted to do it this way is that we don't actually need to store any kind of reference to the original vector except for this row iterator, which is kind of the point. These are kind of like pointers to this object, which is interesting because this allows us to, I guess, make use of pointers without creating a new pointer to this, if that makes any sense. Which I'm not sure if I would be able to create a pointer to this, quite frankly. So this is kind of neat. This is kind of neat. Let me see if we go for it, what happens. Oh no. I didn't really bother to think about all the different test cases. I kind of was like, hoping that we got it. So what happens here? I want to make sure I don't have anything in this standard out. Null true, null false. Expected false. Vector 2D has next. What does that mean? Null, 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 null. Oh, okay. I think it just means that you put null for that command. Okay. So it's a totally empty vector. Right. Row begin. Okay, fair enough. And has next. Oh, that's interesting. Oh, no kidding. Oh, okay. Oh, wow. If they're all empty vectors, so I guess you have to do this here. Yeah, I guess I missed that. Yeah. Okay. Let's see how we do. There's probably a bunch of other test cases. I don't really want to mess around too much. Oh, there we go. Got it. That's a very slight kind of a thing. But yeah, I missed that. I got the in-between case. If you have some elements and then you've got empty vectors in between, but I didn't get the initial case where if you start off with empty rows. That's interesting. That's my mistake. I done goofed. Missed this very subtle detail. That's bad. Man, it's crazy too because I effectively thought of it, but I just forgot to put it in there. I thought of it in the middle. I didn't think of it at the beginning. Obviously, the beginning and the end is sort of the same thing, right? The beginning, the middle, and the end here. But this really should have been right from the get-go. Should have been right in the beginning. Very interesting. All right, well, it's close. Yeah, sometimes you miss it. If I had run some test cases, I wouldn't have missed it. You know, you could argue that like thinking up some useful test cases is part of the problem-solving process. Like you really should be practicing that and learning how to do that, knowing how to do that. You really don't want to hit that submit button, like unless you. Yeah, I think I made a mistake. I should have. I think I was wrong here to do what I did. You want to think of reasonable test cases, and then if you're fairly confident that your code handles those cases, then you hit the submit button. But you don't want to just skip the test cases and assume, oh, I'll just go for it, and assume that I didn't consider these cases. That's wrong. You want to have considered those cases, and then you can skip it if you assume your code. Usually you could just write it though. In this case, I was just kind of lazy. I was like, I'll just go for it. But that's not a good habit. It's not a good habit, and it's not correct to do that. You want to think up a few test cases that, now it's hard, it's tricky. Thinking up the test cases is somewhat subjective to the problem. But usually, you just think of like deformed inputs. So like in this case, if you have empty, your vector itself isn't empty, which by the way we didn't consider if that would be the case. We actually didn't handle the case where the vector is empty. I mean completely empty. What does that look like? I think that gives us invalid input. Yeah, I don't think we'll be able to bind a reference to. What if you did this? I want to say this is just a. This is just bad input. I actually don't know. Hold on 1 second here. Okay, yeah, that's fine. Go to sleep. I'm wondering if I can. Do something like this. Just want to verify what I think. This test case. No. I think it genuinely gives me a. I think it genuinely gives me a invalid input. So I don't think we can use an input like this. Okay. That apparently works, which is interesting. it doesn't work though. Very interesting. So this will give us a runtime exception. This will give us a runtime error. But this one won't. I don't really know what to make of it all. Very interesting. But yeah, the main issues are, right, if you just have a bunch of empty matrices, what happens? Or a bunch of empty vectors in your 2D vector, then, you know, how does your code handle that? That's really the question. And so if you put a bunch in the beginning, and if you put a bunch at the end, put a bunch in the middle, and then you realize, oh, you just need this extra bit of code, excuse me, to handle those cases. Then that's pretty much it. There aren't really too many ways you can mess up the inputs for this question. Obviously, there are some, you know, the test cases I just showed you where the inputs are kind of questionable. I don't really know exactly how I'm supposed to handle those. I'm not even sure. I'm not sure about those cases. I mean, I just went through them slightly, but one of them, it looks like no matter what you do, you won't be able to run it on that input. And then another one I just did, my code seems to fail, but I don't know if their code works or is supposed to work. It's not really clear what to expect for the inputs, because obviously if this is just a vector instead of a vector of vectors, it doesn't really make a lot of sense, I guess. So this is sort of always gonna. I mean, this will just never work in that case, I guess. So anyway, I mean, that's a pretty easy question, pretty easy problem. If you just take it sort of at face value. Not bad. It took me a while. But yeah, pretty straightforward. The logic is really simple. So hopefully that was enjoyable to watch. Hopefully that was, you know, I guess somewhat interesting, I suppose. Yeah, I would like to just take some time, like take a week or something, and just do nothing but code these problems, just for like old time's sake. But the reality is, like, I just have too many problems, too many issues, too many things to look at and work on and deal with, and what have you. I have to contend with reality. Contend with reality. As difficult as that may be. But praise God, thank God, you know, just thank God for everything. And obviously I don't pray when I do these videos, but yeah, it's always worth praying. It's always good to pray. Just be grateful. I'm grateful. I'm grateful. I often, it's a sin, but I'm often in my thinking ungrateful. But the truth is, like, my life is very good. Very lucky, very fortunate. There are so many things that could be wrong with me and in my life, and I'm extremely blessed. Well beyond what I deserve. So, yeah, definitely guilty of sins, you know, envy and jealousy and wanting things that are not mine and all of those things, but all that's just sinful, you know. And I've got to just accept what God gave me, which is amazing. I mean, it's nothing short of astounding. So anyway, let me go. Thank you all for watching. hanging out, saying hello. I do appreciate it. I'll talk to you all soon. Have a good rest of your night. I don't think actually anyone said hello, so so thank you all for watching then, rather than saying hello. But yeah, have a good night. Talk to you soon.